So with this, we go on to what we call the test of independent. Okay, let's say we call it the test of association. So, and this one applies to what we call categorical variables. So when we have categorical variables, so I'm asking who can define, who can try to tell us what you understand by a categorical variable. Categorical.
It's like group data.
Well. What do you understand by the word category? Anybody? Category from the word. So that's where we got our word categorical from. Category.
Group.
Different type of variable.
All right. Let's come back home. I know you're coming up, and gradually you get these things. Now look at what we mean. When we say category, just think about something that has to do with a class, a name. Something that has to do with a class or a name. Do you get that now?
Yes.
So category. Now, so when we talk about categorical variable, it's a variable that does not have anything else to give us, but just maybe a name or class. I'll give us an idea so that you get that now. When we talk about, when we were talking about weight and calorie intake the other time, we could measure those ones. But now the categorical variable we're talking about, we cannot measure a categorical variable with maybe a ruler, a meter or something, as we would have done in the case of maybe weight of somebody or temperature and the others. So we'll come back home. We are talking about a variable that can only be found within maybe that can just give us a reference to something so that we can identify it or distinguish between people, but then you cannot do any addition, subtraction, or multiplication on that. Let's talk about it now. Let's start. There are two types of categorical variables. The first one will be the nominal. Can you say nominal?
Nominal.
All right. So
nominal.
Yeah. Norminal. Now, these ones have to do with names, just names. For instance, yes, it's a variable. Your name, my name, Ade Oluwafemi. You may be Joshua, another person may be Daniel, another person may be Bolarinwa. And then when you put all of that together, those are different names. So nominal variable doesn't do anything more than names. Look at this again. For instance, when we talk about fruits, each fruit has its name. Now, orange is a fruit, mango is a fruit, banana is a fruit, and like that. Each food has its name. The food may be yam, it may be rice, it may be anything. Each hostel in school has its name. Each city has a name. Each company has a name. Those are variables, but they are just names. So that's the first class of categorical variable. The second class is the ordinal. Say ordinal class.
Ordinal.
All right. So this one has to do with names, but also has order. So it's not just a name. Sometimes we may even use numbers to represent what we have in this one. In the nominal case, you may use numbers like 1, 2, 3, like that, up to 1,000, up to, you can, to infinity to denote them. But actually, it's the numbers here cannot be added. For instance, if number 1 represents, let's say somebody's name, and that person is bearing maybe Philip. you cannot say 1 plus, we do this a lot when we do serial number. Serial number 1, 2, 3. So maybe the name here is Philip. Note something, that you cannot say 1 plus 2 plus 3 and then start doing some calculation on this and say 1 divided by 2. Do you do anything on this serial number? Hello?
No, sir. No,
Okay,
sir.
assuming that this is admission number, not just serial number now, but admission number. And admission number 0, 1 or just 1. Admission number 2, admission number 3. You cannot do anything. So if you talk about 1, it means you are talking about Philip, right? Right?
Yes.
If you call
Yes,
admission number 2, you're talking about maybe this one is Daniel. And if you talk about 3, maybe this one is John. You're talking about John. So this is actually a nominal variable, even though you use 1, 2, 3, just as much as Philip, Daniel, and John are nominal. Okay, the name here, as much as the name here is a nominal variable, the admission number here is also a nominal variable because you cannot do any calculation on it. It's just a name or just for identity's sake. All right. Now, ordinal has to do with names, but also with order. Sometimes you may just see names, pure names written like this, or you may see numbers used to denote the names. So that in place of the names, you may use numbers, but you cannot do any calculation, meaningful calculation on those numbers. Sometimes you may see them like this. So let's give an example. This one, the names here has no order. There's no order. You cannot say Philip is greater than Daniel or Daniel is greater than John. In terms of the name, it's not possible. So there is no order. Let me add that here. Without order. All right. Now that you know that, we may look at this now. Now, an example of this is when you talk about class of degree in the university. Now we have first class, we have second class, we have second class. So let me use what we use to denote them. 2-1. We have 2-2. We have third class. And then we have the past degree. Now, note something. These are names, right? Right?
Yes, sir.
Or you may call them categories, as I said before. Now, not names of people, but names of degree. Now, classes now, but there's an order there. For instance, first class is greater than 2-1. 2-1 is greater than second class. Greater than 2-2. And 2-2 is greater than third class, and third class is greater than pass. Is that true?
Yes, sir.
All right, so there is order here. Another one that you may consider is when we say tall, for instance, taller, tallest. Now, supposing we say, okay, we want tall people, all tall people belong to a particular class. The people who are taller belong to another class. The people who are the tallest, so just putting that, then we don't mind me, but just to help you a little bit so that you can understand. Here we did not really specify the number. We didn't say, okay, but just look at them randomly. Two people may have a similar height, but when you check them closely, they may fall in the tall class, but this guy is already taller than this other man with a margin. And you put them in the same class. And the other people in the taller class may also experience similar things. Some of them are taller than the others, but all of them are put in the taller class. And in the tallest, maybe you still find people who are taller than the others. They are all tall, very tall, maybe very, very tall. But there's still somebody who's taller than another person, like that. So that's what you're talking about here. So when you take names or categories, but then there is order, so that you can say this, for instance, this is greater than this one, and this one is greater than this. then it means you have an ordinal variable. So those are classes of categorical variables now. But don't worry, if you don't get anything from what we have done, just be aware that when we talk about categorical variables, we are talking about variables that actually have to do with classes. You can't do any meaningful calculation on that. Please, how do you sum first class with 2-1? Hello?
Yes, sir.
Look at this now. For instance, when checking this thing, now you say class of degree in the university. Now this is a variable, class of degree is a variable, name is a variable, admission number is a variable. Now this one has first class, the other one has 2-2, and the other person has third class. You cannot sum, you can't do any meaningful calculation on this. Neither can you do any meaningful calculation on this. You cannot say Philip times Daniel times John, or Philip plus Daniel plus, it doesn't make any sense at the end of the day. But supposing you take their scores in a particular test or their weights, you can do a meaningful calculation on that. So if you take their test scores and then maybe this man gets a 10, the other guy gets a 9, and perhaps this other guy gets a 7. Now, you can find the average here, and if you look for the average here this time around, I think we should have something like 13. No, not 13. Let's see. That should be, all right, 19 plus 7, that should be 26 divided by 3. Well, I don't know if that may evaluate too, but 26 divided by 3 will be the average. All right. But in the case of the class of degree, you can say, okay, Philip's class of degree is greater than that of Daniel. That of Daniel is greater than John. But when it comes to name, you cannot say Philip is greater than Daniel or Daniel is greater than John. You can't do that with what you have here. But you can also do something meaningful on their weights. You can find their average weight and like that and like that. So these ones, weight and scores, are actually, they are not categorical variables. So they are different. All right. So we go on. Now we want to look at our test of association. So when we have association between two variables, what are we talking about? Okay. Or you may say association of attributes. Now we tend to call our categorical variable attributes. What did I call it? Hello? Hello?
Yes, sir.
Yes, sir.
I said we tend to call our categorical variable attributes. What did I say? Hello, can you hear me?
Yes, sir. I hear you, sir.
I want you to repeat what I've just said. We tend to call our categorical variables attributes. What we measure from them, we call them attributes. So what did I say?
Attributes.
What did I say happen to have attributes?
What we measure from the nominal scale.
That is not what I have said. I said we tend to call our categorical variable attributes.
Okay.
Now, so that you don't hear the word attribute and then you become confused. I hope you get that now.
Yes, sir.
Okay. So, whereas when we talk about numbers now, for instance, the weight of somebody, the this of maybe the score of somebody, we are talking about a metric. We usually use the word variable for that. So, but when we are coming to the characteristic that has to do with categorical variable, we tend to use the word attribute. So, another thing is that, so anything that is qualitative, so not quantitative. When you hear the word qualitative, so you already know that you are talking about categorical. Are we getting that now?
Yes, sir.
So categorical, so you're talking about something that is that has to do with categories. You cannot do any meaningful calculation, computation on each on themselves. You can't, but you can look for maybe their frequency, the frequency of their occurrence. Now, so we want to do that. Look at the case where we have, well, we don't usually write it this way, but I'm going to do that just to make you understand. Then I'll continue my work. Let's look at the case where we actually have a data that looks something like this. Now, some of you, I believe you can still see my screen, right?
Yes, sir.
Okay. So, so as I said, we are looking at what we have called association of attributes. So test of attributes, or let's just say association of attributes. Now, it's like I said before, let's assume that we have a data set that looks something like this. Maybe we have X and Y. And then we have here, F represents female, please. Female. And here, M represents male. The reason why I took time to explain this is because I want you to understand it well. Now, let's assume that we have, for now, we may just have about 4 or 5 of them. What is important is to understand the concept. And we have male, we have female, so X is representing gender, and then maybe we have male again. But here, let's assume we have, let's say, which town the person has come from. So town 1, T1 represents town 1, T2 represents town 2. Now, supposing this is the case, we have this to be T1, we have this to be T2, T3, let's say T1 again, T2, and this person is let's assume T1. Now, when we want to arrange this, usually this is how the data may be, but when we want to do what we call a contingency table, we arrange it in such a way that we have X, which is our gender now, and then we have Y. And mind you, it can also be the other way around. X may come here, Y may go there. What's important is that you understand the concept. Now let's have this. Now there are 2 things that we find with our Y. It has T1 and it has T2. We find 2 things with our X. We have T1, male and female. So male and female. Now we want to put the data you're seeing here now into this shape. When we had T1, how many cases do we have something like T1M? So maybe Y is T1 and X is M. Let's check. Can you count the number of cases where we have that? Let me write it again. How many times? T1M, T1M, T1M. This is, let me get another marker. So this is 1, right?
Yes, sir.
This is 2. Y is T1 and X is M. So we have 2 cases. Now let's take another marker so to make things easier. Now, how many cases do we have for Y is T1 and X is F?
1.
T1F. So only this case. So we are going to write 1 there. Okay. How many cases do we have for T2, Y is T2, and X is M?
1.
One.
T2M. So just this one. So that gives us 1. Permit me to change the yellow color. It's not. All right, so 1. Now, going on, how many cases do we have for y is T2 and x is F?
1.
Only 1. Maybe a different markup or that. So we get 1 also. I don't think. Better. Okay, now that way you can understand that we obtained a table. Now it's possible to have a situation where you have, let's assume that X in gender actually, maybe we just have undefined. Don't mind me, but let's assume that we had a different variable here. Maybe this one is mango, mango. This one is I don't know, any fruit that starts with F. Anybody remembers? Okay, let's assume that this is garden egg, G, and this is maybe carrot. You may have up to 3 or even up to 4 or 5 here, and you may have, it can be more than 2 here also. Do we get that, please?
Yes, sir.
Yes. Okay. So it can be more than, please. So just take note of that. But in this case, we have a 2x2 table. I'm just trying to illustrate what you need to know. Now, okay, maybe we should let's add some other cases. So let's make so that you not get used to the 2x2 stuff and then you become confused. Town 3. So, all right. I will not need to write this again. So just permit me to fill up the remaining places. So assuming we had 2 here and we had 4 here. Permit me to also change this data. I've shown you how to bring a data of this kind from here to this actually. So permit me to do a different stuff here now. 3, let's assume this is 5. And assume that this is 7. Now it could be transposed in that you can have it the other way. X will be here, Y will be there. But what is important is that so at this junction, I want to change some things. At this juncture here, okay. So let's have this to be town. Let's also have this to be gender. Now, having said that, we obtain a test statistic which we define as X. So is a chi-square statistic, that's what we call it. Some people say chi-square, whichever way you call it, just understand that it's spelled this way. So whether you call it chi or you call it chai, whichever one you call it, understand this. So that's and so that is statistic. Now it's written this way and it's squared. And then we write it this way, summation, summation. OI minus EI. We have OIJ minus EIJ divided by, okay, this is squared. And then we divide that. We have a short time left, so okay, we continue. Now you are going to be dividing that thing that you have there on the board by the expected. I know you don't know what those means and what those things mean now for now, but we're going to get there. So you're going to be dividing it by something which we call the expected frequency count or frequency. So now let's now break it down rather. So R means number of rows. Number of rows. C means number of columns.
Consciousness.
Hello, please, you need to mute your mic. Now, so I will take value from 1 to the number of rows. They will take value from 1 to the number of columns. Now, in this case, let's go on. We have how many rows? How many rows?
2.
1, 2, 3. We have 3 rows, actually, my brother. We have 3 rows, not 2. Now, rows are from left to right. Do you get that? This is row 1. Let's put some. This is row 1. What you are saying here is row 1. This is row 2. And this is row 3. Is that okay? Is that okay?
Yes, sir.
Yes, sir.
Yes, sir. A column goes spans from that's from so we continue. I was talking about, so let's look at what I was talking about. There are 2 things to note now. I want you to be very careful with these 2 things. The first one that you must notice is this formula. So there's something called observed frequencies. That's what you actually observed when you were doing your data collection, for instance, like what you have here. Somebody needs to mute this microphone, please. Now, so what you have here, maybe when you were doing your data collection or the data you collected from somebody has this format. Now, when you rearrange it to be like this format now, to be in this format, now what you are going to have is the observed frequencies. That's what you are going to have. But in order for us to have the expected frequencies, we need something than just this. Now that means we are going to have to use a particular formula. So, are you with me? If somebody may need to be the microphone. Don't disturb our class, please. Mute your microphone. All right. So here, when I write OII, you are going to understand that. Please just go with me, please. Now stay with me, please. Somebody needs to mute your microphone, please. Okay, so we have N11. We have
Joel, move to mic.
all right. Let's go on. So we have N11, O11, O21, observe 31, observe 33. Now all of these, don't forget I said this is row 1, this is row 2, this is row 3. Don't forget. Now when we are talking about the columns, this is column 1 and this is column 2. Now going by that, O11 means observed value in the first row and the first column. So that's what we are talking about. That's the meaning of O11. And that value is 2, actually. That's what we have called O11. O12 means observed value in the first row and second column. That is O12. And going in like manner, you get the other ones. And another thing is that we N11 and O11 are the same thing. N21, but they use how we use them, or in which case the cases in which we use them actually are different. So look at something here now. Then what are we going to call these totals here? We need to get some, or need to have some mathematical formula that mathematical ways of denoting, or some notations that can represent this one. So we have, now we have this one to be called N1 dot, N subscript 1 dot. This is what I mean. N subscript 1 dot. All right. Now this will mean N subscript 2 dot. This one will mean N subscript 3 dot. Now when you see this, it means that the row total, the total for row 1, the total for row 2, the total for row 3. The reason is because you are saying that, okay, all of row 1 sum, so although you have N11 here, N12 here, 1 and 2 are no longer showing in that place, meaning that you have summed across the columns, since the second number represents the column. All right, now these ones also will be affected by our definition. So we are going to call this one N2, okay, N.1. So that's what we call this one. And we're going to call this one N.2. So this second one here, N.2. And that means that we have summed across the rows for this particular column. So row 1, row 2, row 3, all summed for this column 1. That gives us N.1. And then N.2 we sum across the rows to get the sum for the second column. That's what it means. Then this one also has a name, and that name will be N dot dot, meaning that we have summed everything. That's the meaning, N dot dot. So that's what this one means. Now I am using two notations. I want you to be familiar with the two. The OI stuff goes with the formula. So conventionally it's used that way. But when we want to discuss how to observe, or rather how to obtain the observed frequencies, then we need to start talking about the N1 dot, N2 dot stuff. So let's do that now. Let me write the formula. Now, in order for you to obtain the expected frequencies, it's not difficult. You just need to understand a particular, or know a particular formula. And what would that be? That will be that we have we have EIJ, so the expected frequency for any of whatever you have here. For instance, by now you should be able to tell that, okay, let me take this away a bit. Make this one go away a little, to give some space so we can write some things. Good. Right. Now, here, this will be, you should be able to tell now that this should be E11, E subscript 1, 2, no, 2, 1, E subscript 3, 1, E subscript 1, 2, E subscript 2, 2, and E subscript 3, 2. Oh, 3, 1. Now, so we go back to define the EIJs now. We are going to have EIJ to become N1 dot multiplied by, so if you like, you may put them in brackets to avoid confusion, but you don't necessarily have to. Multiplied by N dot J, so your I, divided by N dot dot. I will define that. If you see it this way, written like this, it's not wrong. But as I said before, for those who may be confused somewhat, you may use a bracket if you like. But if you see it written like this, the same thing. So let's take just one of it. Whichever one you prefer, you're good. Now, what does this mean? Actually, we are saying that we want to obtain estimated. That's what we mean by expected here now, this time around. Just think about it as an estimated value that, okay, supposing we decide to estimate this ourselves, what should we have? But we are estimating it from the data we have. So expected frequencies will be obtained using this formula. And if you look at our formula here, we just said that N1 dot is this and N dot 1 is this. Oh, okay. Now, 1, don't forget I represents your row and J represent your column. So if we want to look for E expected value 1, 1, for instance, it means you are going to multiply the sum for the first row by the sum for the second column. This is 1. Then you divide by the total. Now, so what are we going to do? N1 multiplied, okay, let's start from N1 dot, you can see that here, multiplied by N dot 1 divided by N dot dot. So we are going to multiply to get E11. It means that we are going to multiply 9 by 7. We are doing that with the totals. Don't forget, 9 by 7 and divide by 23. Do you get that, please?
Yes, sir.
Divided by 23. So that is going to give us what we have here. Now I'll take one more, then I'll stop there. You can figure the rest by yourself. We are going to multiply. So for the next one, if we want to obtain, sorry. If we want to obtain E12, it will now become N1 dot multiplied by N dot 2 divided by N dot dot. That will give you, what is N1 dot? N1 dot is 9. What is N dot 2? N dot 2 is 16. So you multiply 9 by 16 and divide by 23, and that will give you what you have here. Now, having obtained that, let's do it for the third row. So you may do the others yourself, but okay, we may continue. N21 will become N1, okay, N2 dot multiplied by N dot 1 divided by N dot dot. That will become, what would that be, please? Anybody who can try? Anybody who can try? Nobody?
That's 16
16? It's not 16.
times
Again. 8. 8. Say it again. N dot, N2 dot, not N dot 2. N2 dot. N2
okay.
N2 dot multiplied by N dot 1. So that N2 dot is 8. Then N dot 1 is 7. You can see that there. So 8 times 7 divided by 23. So that will give you what you have here. Then you go on E31, Quadri. Can you just please let me finish? Then you ask your question. Sorry, please. N dot 1, N1 dot divided by N dot dot. That is going to give, in this case,
6
N3 dot is 6.
times
By N dot 1, that will be 7.
7.
N dot 1 is 7.
Yes, sir.
Okay. And N3 dot is 6.
Yes, sir.
So we get, okay, 6 multiplied by 7. Oh, there's something we haven't done. Okay, no issue. We'll continue. 7 divided by 23. So we did not do E22. So we're going to do that now. E22 will be N2 dot N dot 2 multiplied by N dot 2. Sorry, N dot 2 divided by N dot dot. And that will be N2 dot is 8, N dot 2 is 16. So that will be 8 times 16. 8 times 16 divided by 23. So in all cases, we are dividing by 23. And then for the last one, E32 will be N dot, okay, N3 dot rather, multiplied by N dot 2 divided by N dot dot. And that will be N3 dots is 6. And N dot 2 is 16. So we have 16 multiplied by 6. Wait, did I get it right? N3 dot is 6. Okay, 6 multiplied by 16 rather. 6 multiplied by 16. I believe I'm correct.
Yes, sir.
So 6 multiplied by 16, that's what we just said now. So 6 is here, N3 dot, yes. N2 dot, N dot 2 is 16, yes. So that's correct. Now, so when you do that, you are going to obtain what we had obtained earlier, on here, and that's just it. So, Quadri, you can ask your question now. I'll listen to you. Quadri. Is Quadri no longer there?
Yes, sir.
So I'm listening to your question.
Hello, sir. It's clear now. I don't have question again.
That's why sometimes you may need to wait. If I said you may end up understanding it, but it may just be a disruption that could have been avoided. All right, so that's fine. Now we.
Sir, I have a question. Please,
you can ask.
Okay,
you can
thank
ask. I'm listening.
The N dot 1 and N1 dot.
Yes.
Please, how is the question? How is the question look like before we get the end of?
How did the question look like?
Yes, sir.
This is what we used to obtain them. The table here. This table. It is this table that became this by this transformation we are doing here. Using this one. Do you understand that? Hello? Was
Yes.
Quadri in class
Yes,
when we
sir.
started? Were you in class when we started?
Yes, I was in class.
Yes, I told you that you may be given it, if sometimes maybe in the test situation, you may be given the data like this. But in real life situations, nobody gives you data like this. You are the one who will have to make your data become something like this. This is what you'll be given, something like this. You get that
It
now?
is that.
So
Yes, it is
when
that
you
amount.
do this, you now need to, you don't, typically you will not use your eyes to be doing all of what we just did now. Just did that so that in case you see it and it's not so much, you may do it yourself. Perhaps in a test situation you are given like this, you can also make it become like this because this will make it easier for you to solve. You find it very difficult to solve it and obtain this if it is like this. So, but when it is like this, you can obtain your expected frequencies. Did you get
Yes,
that
sir.
now? A computer will usually do that for you. But if you don't understand the basics, how can you, for instance, now, you may not have a standard package that can run stuffs to become like this for you. So you may need to write the program yourself. If you don't know how it works, you can't write the program. Do you get that now? Hello?
Yes, sir.
All right, so that's that. I believe the answer, you've gotten the answer to your question. All right. Now, having obtained that, we continue. Quadri, have I answered your question? Hello? Quadri. All right. We continue. Can you hear me, please?
Yes, sir.
So we continue. Now we are going to be removing the OIJ from whatever. So in this case now, our row, number of rows, in this case, R is equal to 2 and C is equal to, R is equal to 3. 1, 2, 3. Don't forget 3 rows and 2 columns, 1, 2. So R is 3 and C is equal to 2. So because of that, we are going to be having our formula become something like I equal to 1 to 3 rows, J equal to 1 to 2 columns. And we'll have O ij minus EIJ squared over EIJ. Now, how do we do that? So we are going to be doing that now. In that case, let's start from the first one. The first one says, we have a 2 there. Okay, so it's an error. 2. Please, at this point, you need to bear with me. Please, somebody needs to mute your microphone, please. So I believe you are accustomed with the formula, so let me take them away. Maybe bring them down here. So don't forget the X square stuff you're seeing there is the chi-square statistic. Now we are going to be doing this. Please take note. So now we are going to be using what I've written up there for this. So how did I get this now? Don't forget we are doing OIJ minus EIJ divided by EIJ all squared. And we are summing this row and column, just the way we've written down there. But I'm just writing this so that you know that it is OIJ. So let me put this by the side. Well, we put this by the side. That's what we are doing, please. In case you're confused at any point, this is what we are doing. So please, you can visualize it up here. So now, I've taken the first observed, which is 2, and the expected for it, that is E now, is 2.7391. I've taken the difference between them. I'm squaring it now, and I'll divide by the expected count. That will be 2.7391. Now, we'll go on to the next one. That will be 6.209. Oh, sorry. No, for the observed test. The observed is 7, while the expected is 6.2609. So we square that, divide by 6.2609. The next one, permit me to write, ordinarily I should write it on a straight line, but the book, and even your exercise book, while you are solving on in an exercise book, you may not be able to write everything as you want to. So, I mean on a straight line. So you can always come down and continue. Just make sure your equal to is properly written. Now we go to the next one, 021. That gives us 3. The observed gives us 2.4348. And we are dividing that by 2.7391. This squared. All right, so we'll go to the next one, and that will be 5. Oh, sorry, please, there's a mix-up. This should have been 2.4348. The observed here. Expected here. Now we go on. So the next one is 3 or 5 rather. 5. Observed 5. Expected is 5.5652. That gives us that squared. Then we divide by 5.5652. All right, so we go on to the next one, and that will be 2. So that 2 here minus the expected version of it is 1.8261. So we square that and divide by 1.8261. Then we go on. We do the last one. We are going to have 4. This 4 here, and minus 4.1739. 4.1739 all squared divided by 4.1739. So that's all. Now, in that case, we can now sum everything after doing our computation. Now, there is one thing I did not discuss before we do this. I didn't discuss before now. It is the fact that how you know that you are correct when you obtain the observed frequencies is that you are going to have the same, although different figures here in T1, T2, row 1, row 2, row 3, the totals. The subtotals will be the same. So you have 7 here for column 1, you have 7 for column 1, you have 16 for column 2, you have 16 for column 2, you have 9 for row 1, you have 9 for row 1, you have 8 for row 2, you have 8 for row 2, you have 6 for row 3, and you have 6 for row 3, and the total of the subtotals now is 23 here. It's also 23 here. So take note of that. Do you understand that, please?
Yes, sir.
Now, that being said, we can now begin our calculations. If you have a calculator with you, you can calculate. It's a calculate too. So we are going to have 2 minus 2.7391. You can validate what I'll be doing so that if at any point there is an error, you can let me know. 731. That should be 0.1994. So please, if you find anything that doesn't look like it, you can let me know. All right, 7 minus 6.260, 2 divided by 6.2609, that becomes 0.08. 0.873, then plus the next one, we have 3 minus 2.4348 square, 2.4348, that will become 0.1312. Then the next one, 5 minus 5.5652 square divided by 5.5652, and we get 0.0574. And then we go on to add the others. To save our space, let's just write it downwards here. Okay, so write it down here. Now we are second to the last one now. We get 2 minus 1.8261 squared. 2 minus 1.8261 all squared. That will give us divided by 1.8261. 0.0165, 0.0165, 6, and then the last one, 4 minus 4.1739 squared, we'll get divided by 4.1739 0.007, and then we get 3. All right. Now, adding all of these, you are going to get, so you can validate as I do mine. So if there is any mistake, we can consider and correct it. So according to what I have here, that should be 0.4992. Let me check again. 0.1994, 0.0873, 0.1312, 0.0574, 0.0166, 0.0073. All right, so that's correct. And now we've gotten our test statistic, but we need to know what we have in the table value. Now, note this. This is the general rule. What we are trying to see is that is there any connection between, don't mind me, I'm saying, okay, yeah, is there any connection between living in town, any of these towns, living in a town, and the gender of a person? Do you get that now?
Yes,
so maybe like if you have this gender, you are likely to live in maybe town A or town 1 or town 2 or town 3, thereabout. But if you have this particular gender, you're not likely to live. So maybe perhaps being of a particular gender affects which town you stay in. Don't mind me, even if it doesn't make any sense anyway, or it looks like it doesn't make any sense. But we are trying to check if there's an association between the two. And don't mind me, actually, I could have used something. So T1, T2, T3 could be anything else. Perhaps maybe class of degree, for instance. Perhaps that your gender affects your class of degree. So just understand that from there, even if you do not understand, or rather this term 1, term 2, term 3 doesn't seem to make sense with the gender stuff. All right, so rejection rule. The rejection rule states that it's similar to what we did before. So it's not difficult. It's just that the table for this one is different. Now, the rejection rule states that reject H naught if chi-square that you have calculated is greater, the statistic that you've calculated is greater than, this one is written the way I've written it, please. It's not written as X. It's written with the, you get that now, like that, please. Chi-square with degree of freedom, R minus 1 multiplied by C minus 1. R minus 1 multiplied by C minus 1. So R is the number of rows. I said that earlier on. You can see that there. And C is the number of columns. So don't forget that. Now, it means that we need to obtain some things, but what's our hypothesis actually? The null hypothesis. So there are a number of ways to write your hypothesis. Now, please, it's either you say the gender of student and the type of house they live in are independent. That will be your null hypothesis. And whenever you reject the null hypothesis, in this case, it means that there is independence, because you have said in that hypothesis that the gender of students, I'm assuming that we are considering the gender of students, and the type of house they live in. Don't forget I gave the data there the other time. So usually you get enough information from your data set to be able to know how to put your hypothesis, but you are the one who will know how to construct it the way you like. Now, the gender of students and the type of house they live in are independent. Don't forget, this hypothesis always says that the two variables you are giving are independent, but the other hypothesis here, the alternative, always says they are not independent, meaning that they are dependent. If they are not independent, they are dependent. Another way you could write your hypothesis is to use what we call association. The word association shows that they are dependent. The word no association means that they are independent. Do you get that now, please? So you are supposed to say there is no association here, then there is an association here. there is an association. So when there is an association, there is dependence. That's what each one is saying. Each one is always saying that they are dependent. That means there's an association between them. That's why you see the word not independent here. But each note always says no association. See it? No association. And by saying no association, it is also saying that they are independent. No dependence between them. All right. Now that we know that one, we can now go to make our hypothesis now, or rather to reject or not reject the hypothesis stuff now. So we look at the rejection rule. So, but how do we obtain this? We already have this, but we don't have this yet. So let me get this one. Now the chi-square thing is going to be, so our test statistic R minus C minus 1 equal to, so we already said what our C is equal to the other time. So please, it's good to define this. You just write it somewhere. Let it be known that you know what you are doing. Define it. So it's good to just say something like where R is this and C is this. So it's not a bad idea if you have written that before, and maybe you bring this down. Where R is this and C is that. Then you can have your chi-square statistic to be this. So it will become equal to chi-square 3 minus 1, 2 minus 1. So you're multiplying actually. And that will become, please endeavor to write your chi-square stuff like the way I'm writing it. Don't write it to be X like this one that you are seeing here. This one shows statistics that you are computing yourself. This one shows the standard table, the table value. Do you get that, please? Do you get that, please? Are you with me? Can you hear me?
Yes, sir.
So please take note of that to avoid, and there is something that is missing that I did not put. There should be a square. It also takes a square. The only thing is that whereas the statistics you compute is, please, can you undo what you have just done, please? Thank you. So you can have this one. This is the test statistic, but this one is the table value. So we go on. You're going to understand that now. So 3 minus 1 is 2, right? And 2 minus 1
Yes,
is 1, right? So at the end of the day, this gives us, you could just write it directly. Don't need to do all of this that I've done here. So this gives us chi-square with 2 degrees of freedom. So let me write that directly. That will be 2. Now we have this. But how do we look at this from our table? Well, we need to look at the table. So I've downloaded one. I would like to share my screen so you can see the one I'll be using. You can get one, but what is important is that you know how to interpret what you have on the table. Now, looking at this, I haven't used this table before, just got it for this class. Okay. So let's go back first. We need to look at something, then I'll come back there. Because if I just do that now, some of you may be confused. There is something I did not include here before. There is a need to put your level of significance, and that's what I didn't do. There is seldom any statistic that you use in your for the parametric kind of statistic stuff that will not require a level of significance. Now, in our case, we usually use level of significance to be 0.05. So we want to put 0.05 there too. So in this case, it should have become something like, it should have been something like, we'll have alpha here, then comma. So that's what it should have been. And here, alpha is 0.05. So need to push this a bit to the left. Okay. Now we can have 0.05. Then we can have a comma. So all of that. Now this one, so we have 0.5. If you have to attend to something, the microphone. If you can talk to the person. Young man. So we will have this, as I said before, then we'll have 0.05, comma, then we'll have 2. Now that we have this, let's go back to our table. So going back to the table, oh, I need to share screen again. Now, this is my table. Now, basically, you look at a few things here, and you really want to see degree of freedom is what we wrote as a 2 the other time there. So when we said R minus 1 multiplied by C minus 1, and that gave us 2. That's our degree of freedom. So our degree of freedom in this case is 2. Our level of significance is 0. Is 0.05, and that means what we are looking for should be 5.991. Do you get that, please?
Yes, sir.
Let's go again. Degree of freedom is 2. Our alpha is 0.05. So look at this very well. This means 0.05. Please look at this, 0.05. So since they put point here, it means 0.05. So the 0 after is not significant. You know that, or you should know that. And so when you look at 2 here and 0.05, they meet at 5.991. And so that is how we get what we need, the level of significance or rather the chi-square table value that we need. Now we can return back to what we are doing. Now, what did we get again? 5 point what?
0.
5 point what did you get again? Look at the value again. 5.991. Okay? Yeah. So return to our work. So we had obtained a value of 5.991, and but our calculated value was 0.5992. Do you see that, please?
Yes, sir.
Therefore, our x squared is this. Now, it means that from what we have done, then we need to, if you look at this, it means that chi-square is less than this, so we can't reject H naught. It means that they are independent. Do you get that now? Let's go back. So we conclude that since x squared equals to 0.499, is that it? 4992. So permit me, because we have three significant figures for the other one, I want to change this to three significant figures to facilitate a good comparison. Is less than chi-square, that's the table value now, 0.05, 2, which is equal to 5.991. Don't forget, our rule earlier on says reject H naught if chi-square is greater than the table value. I mean, the chi-square statistic we compute is greater than the table value. So if it is not greater, then we cannot reject H naught. So since this our calculated chi-square value is not, or chi-square statistic is not greater than the table value, we cannot reject. We do, okay, all right, we can write that. We do not reject H naught. Don't forget the statement in H naught. The statement in H naught says that, what did it say? There is no association between the gender of students and the type of houses they live in. So we are going to conclude based on this hypothesis because we did not reject it. If we had rejected it, then we would have concluded based on the H1, in which case it would have been that there is an association between the gender of students and the house and the type of house they live in. But here, we are going to conclude, and we therefore conclude that there is no association. This should not be there is no association between. So let's see. Yeah, that's it. So we therefore conclude that there is no association between the gender of students and the type of house they live in. Do you understand that, please?
Yes, sir.
Okay, so that's what we are trying to do here. So you see that in this case, going back to where we started from again, the variables are categorical. It means that there is little to what you can do. You can't compute, for instance, you cannot find the sum of male and female. Doesn't make any sense, right? Right?
Yes, sir. Yes,
I'm not talking about counting then. You can, of course, you can count. What we have worked on here is count. This is count data actually, and frequency count. Usually call it frequency count. That's what we can do. We can only count the number of males. Female, okay, male. So like we have 3 males here and 2 females. But here, you can count the number of houses that are of type T1 and the houses that are of type T2 and like that. Now, but when it's put in this place, it's now a bivariate kind of stuff, but for categorical data now, you have it that, okay, 12 people actually are of gender, of male gender, and they live in house T1. Three people are of the male gender, they live in house type T2. I don't know if you so that's just what you do there. But we are not just concerned about having our data like this. we really wanted to make something out of it to see if there is any association between the two variables. Perhaps people, because now we just said that there's no association. If we had said there is an association, we may trace the data here, just check what the frequency that we have here and say, okay, it looks like if somebody is female and okay, if we have, for instance, we have 7 here. Let's look at this one now. 7 females who live in type T1. So we may want to conclude that if somebody is a female, okay, people who are, I mean, the female gender kind of like to live in house type T1. So it looks like it's common among them. Are you getting that, please?
Yes, sir.
Okay, so we may want to look at that, but we really may not just end everything there. If you did not forget your probability, when we did probability, the Bayesian stuff, the total probability stuff, and the joint and conditional probability stuff, I believe you still remember.
Yes,
Hello? Hello?
Yes, sir.
Aisha.
Those stuffs are really handy here for you to get certain things out. So you may want to find the probability that somebody is female, given that she lives in house T1, probability that maybe the student is male, given that he lives in house T2, T3, like that. So all of those things are also useful. You could use them here. But our concern is that we want to find out if there is actually an association between the gender of the student and the type of house they live in. Now, but we, after our calculation and following the rules we had laid down, we could not actually say there is any association between them. And that's what we do in chi-square test of association. So you cannot use correlation coefficient when you are talking about categorical data, although you can use correlation coefficient when you're talking about data that is of continuous type. Do you understand that, please? Hello?
Yes, sir. Yes,
All
sir.
right. So with that, we are done with the course.